Hi, today we will discuss the design philosophy used in reinforced concrete. We have two design philosophies existing, that is the working stress design or WSD and the strength design method or SDM. WSD is the main approach used from early 1990s until the early 1960s, which is focused on conditions at service loads, that is at the maximum loads under the intended use of the structure, and this is what we call the elastic method. Also we have the SDM, which is the prevalent procedure used in practice, which focuses on conditions at loads greater than the service loads. When failure may be imminent, it deemed conceptually a more realistic approach to establish structural safety. You have to take note that both approaches provide approximately the same level of safety and serviceability. So, if you are asking what would be the best method, WSD or SDM, take note that they have the same level of safety and serviceability. For the strength design in 1956, ECI code was the first that officially recognized and permitted the strength design method. And in 1963, ECI code treated the working stress method and the strength design method on an equal basis. But actually, the major portion of the working stress method was based on strength. With the relegation of the working stress method to a small section referred to as the alternate method, the 1971 ECI code entirely accepted the strength design method. Between 1971 and 1999, the ECI code had the alternate design method in an appendix, that is the WSD, but it was removed from the 2002 and subsequent editions of the ECI code. For the working stress design, the structural element is designed under service load condition. What does it mean? The actual load or the working load, which do not exceed some pre-designated allowable values. Also, you can apply factor of safety or FS to strength of materials for allowable stress level, that is F sub A. The working stress method may be expressed by the very simple formula, that is the stress. We normally say stress or symbolize it as small letter f. The stress F should be less than or equal to the allowable stress F allowable. Or stress from the service load should be less than or equal to the allowable stress F sub A. Normally the actual stress is small letter f and the allowable stress is capital F. So that's the difference between the symbols. Take note that the small letter f is an elastic stress computed under service load. And F allowable or allow is a limiting or allowable stress prescribed by a building code, usually percentage of FC prime for concrete or Fy for steel. Of course, for concrete, normally we take the allowable stress to be 45% of FC prime. FC prime is the specified compressive strength at 28 days. So this is the design strength that we normally use in the design of reinforced concrete. For the steel, we use F equal to half of Fy. In the method WSD, there are obstacles that we have to face since the limitation is on the stress under the total service load. There is no simple way to account for definite decrease of uncertainty of various kinds of loads. Generally, the dead load is known more accurately than the live load, which may have a known and variable distribution. As you can see, we are talking about the working stress or the actual load. So possible there will be, like for example, for a residential house or a residential building, there will be two persons walking, or three or five, or possibly 10 if you have a party. If you have a large party, maybe 20. So there is uncertainty of that kind of loading. Also, creep and shrinkage of concrete, which contribute major time-dependent effects on structure, are not easily accounted for by calculation of elastic stresses. Concrete stress is not proportional to strain up to its crushing strength, so that the inherent safety provided is unknown when a percentage of Fc prime is used as the allowable stress. Aside from the working stress design, we have the strength design method, or WS. We call it formerly ultimate strength design, that is USD, but now SDM, or the strength design method. The service loads are increased by certain factors to obtain the load at which failure is considered to be imminent. The load is called the factored load because we multiplied it with the factor normally greater than 1, or the factored service load. At factored load condition, the structure is about to fail. We will be using this simple equation in SDM. The strength provided should always be greater than or equal to the strength required, that is to carry the factored loads. And the design strength should always be greater than or equal to the required strength. We can apply the factor of safety in design via, of course, the load factors, which is greater than 1.0, applied in the required strength. Also, we can have the strength reduction factors, which is normally less than 1, applied in the design strength. So looking at this equation, design strength should be greater than or equal to the required strength. Normally, we multiply the design strength with the strength reduction factor, which is less than 1, and the required strength is multiplied by load factor greater than 1.0. Okay, that's all about the working stress design and the strength design method. And of course, in our course, we will be talking about more on strength design method. That's all for now. Thank you.